And the live stream is up?
Yeah, the live stream is up.
All right. Okay, so let me introduce the next speaker, Taylor Troesh on Publishable network contracts in Scrapscript. And so please go ahead.
Hello all, thank you for coming. I slightly altered the title because I generalized things a bit. I got some very good feedback from the committee, and hopefully this will be a little bit more useful for you guys. There we go. So this is just a brief overview of the type of things I'm going to be talking about. This is a brief outline, and I just wanted to start with the outline because I am part scientist, part programmer, and part entertainer, and didn't want you guys to be worried that I'm going to get to the meat. So this is the meat that's coming. I'm a web developer by trade. I'm not smart like you academic folks. People pay you to push the boundaries of knowledge, educate future generations. People pay me to write websites that sometimes work. 1 million monkeys on 1 million typewriters may eventually write Shakespeare, but we monkeys have already given you the internet with our million typewriters. You guys are wizards, and you've given us web developers many good things. Oh, look at that. You've somehow, beyond all odds, taken JavaScript to TypeScript. That is lovely. One of the wizards over at Harvard, made Elm, which I get to work with on my day job. It's a statically typed beauty. It's a diamond of a programming language. You guys have made Rust lovely, more safety in the world, very, very good. And so I'm here to submit a formal complaint that distributed systems need some work. It is not fun to program distributed systems, and the distributed systems are everywhere. We desperately need some work here, and I do think that soundness and good type systems are part of the solution. So before I get into the theory of things, my day job looks a lot like this. I have to talk to servers, and the servers they have all of the power but share none of the responsibility. It's like sometimes your messages please the gods and sometimes they do not. That's what it feels like to work with other people's servers. I'll give you a specific example. Google is a notoriously capricious god. They main an official Node.js client to communicate with their servers. I just noticed this. The official Google, the last build is failing. Good for them. So I was helping out a friend with some YouTube API stuff, and so I look in the documentation and I'm like, okay, I think I have what I need. I go to use their official client and not in the TypeScript. I'm like, okay, but the TypeScript and the JavaScript side of things are not actually the same. So I look through the JavaScript, okay, not there either. So there's not a problem there. But it is in the documentation. I reach out to YouTube support, and they're like, okay, yeah, the documentation is sometimes ahead of the client. You can implement this as an HTTP request in this fashion. So I do that, and it's not actually quite right. The output doesn't match the documentation. So go back to YouTube support, it gets escalated, and oh no, I'm actually looking for an undocumented API that must be enabled on my account. They did that for me, sent me documentation as a PDF via email, and ta-da, it worked. that is what it feels like to work in the web nowadays. This is not just Google though, and it's kind of everywhere. This like fragmented feeling is really pervasive, and it's also not even just web. It's if you have ever done game development, you will know that these like dynamically loaded libraries on the front end, and you pack the homebrew on your Macintosh. Things get out of sync. Many of you guys are researchers, so Python 2.7 probably keeps you. Gives Python 2.7 PTSD, right? Various programming language and frameworks have tried to do things to reduce this fragmentation. TLA plus, for instance, is not a type system that you would use in TypeScript. It is some external thing to prevent certain classes of errors. All of these kind of fit into that same bucket where they are trying to prevent certain classes of errors amongst the many computers that are trying to interact. When I've been really thinking about this problem, and there's a few underlying things that are all unified here. There's no machine verifiable link between documentations, types, schemas, requests, responses, and addresses. All of that is just kind of like ad hoc floating all over the place. And because of all of this, when I am a client, I'm implementing a client, I am forced to take the server's word for everything. When they return 400 or 500, I actually do not know whether or not they're telling the truth. I just have to take their word for it. The errors that they give me, there's generally no, they're not documented anywhere. So I receive errors, and the errors are not documented. So I have to, often parse strings and work in meat language instead of letting the computers handle classes of errors. And all of this is versioned with something that looks like /API/v2, which is just an ad hoc versioning system built on top of all of this. And there's no real standard, and even the companies themselves don't follow their own patterns. So all of these, I feel like, stem from a common attribution error, common attribution errors. There's no automatic way to blame misbehaving servers. When you're a child, the way that you stop misbehaving is to play blame games, right? You have to figure out the rules of who's correct and who's not. Don't hit your sister. Well, she poked my eyes. He put a leech in my shoe. She called me ugly. He started it, right? You have to like do this whole thing to figure out what the formality is. That's how you develop manners. So when I'm thinking about playing these blame games, here's an example of a network. You are Albert, and your ex-wife Betty, she has the address and the mail, and you want to just send very nice letters to your daughter Clara, and the courts have given some parameters about how often and what kind of letters you're able to send, but Betty doesn't want that communication to happen, so it's a whole complicated thing, and there are ways of formalizing the system so that it does work for everybody. That same system can also be used to enforce the opposite situation, where your other ex-wife, Barbara, who you are in very good terms with, and your piece of crap son, Charlie, who you need some information from. Charlie is exceptionally good at predicting the next day's weather, and you also want the courts to be able to enforce some communication there. So this whole blame game hopefully should create a formal system that works in both scenarios and many other scenarios. It's the general premise. What I came up with is this notion of responsible servers. This is if I have all of these properties, I think I'm going to be able to communicate with many different types of servers, hostile, non-hostile, and it should feel pretty good. Like I am reasonably happy with. I'd be reasonably happy as a web developer or a game designer, whatever, working with distributed systems with these types of servers. Now, I tried very hard to make this work with TypeScript land, some of the more popular stuff, but either I am not, I don't have enough energy or patience or brain cells, so I'm off in my own little corner making my own programming language called Scrapscript. Scrapscript is a pure functional programming language like Haskell, but it's shaped like JSON or XML. It's shaped like a data format, but it's got functions, it's got control flow, so it is a full programming language. And it is typed, and the types themselves are data just like anything else. So it has a bunch of really interesting properties. One other thing that is nice about my programming language, Scrapscript, which has an awful name. It's hard to even say it. It's like choking on like dry crackers or something. Every chunk of the language, I call them scraps, every sub-program, everything in the language can be replaced with a hash of that chunk. And so the language itself ends up being shaped, programs end up being shaped like Merkle trees. So that also provides some interesting properties. Everything becomes content addressable. You can store a whole bunch of stuff wherever, and you can always guarantee that you will get the same program eventually if it's the scraps are stored on different computers. And if we already have all this cryptography junk lying around, it makes sense to sign these little snippets of code. And so authorship can be verified. You can prevent certain types of rot and forgery from occurring in your package managers with this kind of stuff, and it's a cool system. The monkey at the monkey on the typewriter at the Wizard conference. I made a thing in my language that might do some of these things, and the really dumb current thing I have is. You use contracts to specify server can say, hey, I'm going to be at this place, an IP address, and I'm going to be here for a certain amount of time. I commit to being here. If you're here late, it will be unsafe, and I will abide for this period of time at this period of place by some protocol. So this is type definition, request and response are type variables. So here's what it might look like. Without dependent types, you have to use some DSL to be able to define the shapes of things at the value level. But this is the general notion, right? It should make sense. Obviously, there's already one big thing that all of you are probably thinking. What's up with unsafe at, right? Like that, it's a timestamp, and timestamp is not correct. Like this breaks the laws of physics. You're 100% right, and that's part of why I'm at the Wizard conference. I have no idea how to improve upon this. This seems to work good enough at non-relativistic speeds, but if you have any ideas on how to make this work, without introducing hard timestamps. That'd be wonderful. Here's text is small, but I gave an example of what it might look like full conversation or full API. This is like an API definition that you can get from this server, and you can go and have a full request and response party. Okay, but once again, these are monkey solutions to monkey problems. I am at the Wizard conference. Why am I not complaining at the monkey conference? I want, what would be amazing is if we could get something like this working, and we can know that it's correct, right? Like you guys have all of these mathematical tools to ensure that something like this could have some nice guarantees, and I've not been able to find any monkey tools for this, and the wizard tools that I have found seem insufficient. So I think I'm going to talk about that next. Before that, I'm at the UNSOUND workshop, and some of you may have already noticed, I'm not talking about unsound systems, I'm talking about incomplete systems. A formal system is unsound if you can construct a contradiction from a blank slate, right? But I'm really not talking about that. I'm talking about propositions that I want to be unsound in some system. It's like car traffic. The road may be well constructed, everybody may be obeying the rules, and so the whole system is sound, but traffic still can occur, right? Like there are unpleasant externalities that could happen at a high level. So I'm really talking about this, which I think is I've heard the word safety being thrown around. That might be a better word for these properties. It's sound but unsafe. I've been calling this property soundless in the system. The wizards would say that the propositions are independent of the formal system. I like soundless. The tree falls in the forest, doesn't make a sound, blah, 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 blah. So thank you for being here today, and thank you for listening to me. I'm going to get into more details. Here are some possible properties. I'm going to go through quite a bunch of different properties that we might want in a responsible server contract protocol, right? Bunch of different properties. This is the collection of things that I think would be fun to formalize at some point that I cannot find any way to formalize right now for the most part. So first thing is you have a protocol. We have this contract, right, between two computers. How can we guarantee that the contract, the thing underneath the contract, can be amended and still have the whole system remain coherent, right? Like that is a very nice property to have that I don't think I have. Let's see, gRPC kind of has it, but you can only add fields to your contract over time. Universal, does this thing have to be, I would prefer if this thing did not have to be implemented in Scrapscript. I do not want to, that just sounds like a bad thing. It sounds like this should be a shape of something that can be extended to JSON, XML, etc. That would be nice if we'd have responsible servers across the world in any language. The properties of contracts that we might want. Can the contracts themselves, can both server and client, can they agree upon updates and do those updates? Or do they have to wait till the unsafe period elapses? Is there always, actually, I'll wait for that one. Can contracts overlap, right? One way of thinking about doing migrations is that you have a contract that goes until some time, and you start the next contract before that, and you allow the client to kind of hop contracts. They have some window. So that pattern implements a lot of problems for both client and server, and so there's a lot of interesting problems there once you get into the weeds. Contracts themselves, whether or not blame can always be assigned. You can imagine a contract where it is not completely clear, even though there are terms, it is not completely clear who bungled something on the request or the response, right? You can also imagine contracts that aren't completely deterministic, that might not be a quality that you want. A whole bunch of really cool qualities that you can start thinking about with these contracts. And once again, I think some of these, I feel like wizard tools really work well, and some of them I'm having trouble finding clean ways of thinking and expressing this. So I would love to know, amongst all these properties I've talked about, like which ones are, like some of these properties may just be absolutely impossible. Some of them may be mutually exclusive, right? It may be the case that you can't have unambiguous contracts that are also arbitratable by a third party, right? It could be the case, something like that. Cap theorem type stuff, right? I have tried thinking, using a few different systems to model a lot of these properties. Some seem to work okay and some don't. PyCalculus for this type of problems was kind of where I started and wasn't really able to make it work how I wanted. With all these types floating around, just didn't feel good. Linear types didn't feel good either for most of the time. Temporal type theory it uses sheaves to create behaviors, and it's like, I think somewhat it starts getting into like the category theory stuff, and I think that's a little just overkill. But we do have some good stuff. What is the good stuff that might be promising? The first is this one paper I found that talks about contracts for web services. Sounds within the realm of stuff that I'm talking about so far. And I like it. Seems useful. Also, don't quite see a way to get this wizard tool clearly into the monkey typewriter realm, but this is a very good start. You can guarantee a lot of really nice properties when you start talking about lots of computers working together. So I do like this. Scrapscript with the shape of thing that I talked about with dependent types seems to work pretty well. You can just use dependent types and to check the unsafe thing at compile time and make sure that you can tune that. So there's a clear working implementation. The problem that I don't like is, yes, you can have something that checks at compile time, but there's no real extra niceties to reason about this thing and implement nice static analysis tools on top. So another thing I was thinking is, okay, throw some refinement types in there, right? So at the bottom, I threw like, okay, if you construct something like this internally or or in the syntax, you can say, okay, this contract has like a subtype of location and for a given amount of time, right? It's valid for this. That way, you can have a you can write code that will complain if you're sending it to the wrong place, or if you're sending it at a time that's invalid. It will add expiration dates to certain parts of your code. So that could be something interesting. With this, one nice thing is that you can you can fetch contracts from a remote source and still act upon them, right? You don't know the explicit time and place, but you can write code that survives that not knowledge at at compile time, and still you're able to make coherent programs. So that's a nice feature. Another nice feature is you can compose these contracts. So you could have multiple times and places that things work. In a migration scenario, you might have something like this, where it's like, okay, I have some implementation, and I just want to make sure that my implementation is good throughout this window. And so you can do things like this. If we steal from Rust's lifetimes model, it might be good to have like these addresses and durations. Just give them unique type variables in the program, like lifetimes, but they would be something like server lifetimes. I have thought about this, and it seems pretty unergonomic, but could be fruitful. There are some nice properties about it. Yes, with the session types, right, it might be nice to be able to enforce strict ordering of these contracts. So you have to send a message before you receive. You have to request an OTP code on your phone, like the SMS message, before you submit it. Right? Like you can enforce ordering like that with session types and a few of these other models. But yeah, that's it. Thank you for coming, and I hope this was either entertaining or informative. Yeah, thank you.
Any questions? Please feel free to ask. Okay, I'll start again. All right. Yeah, very interesting topic to present here. We are, so I think in this community, we often say that session types are the supposed solution to this kind of problems, right? Distributed programming and protocols. You said that you looked into them, and they seem to be part of the solution. So in what way are they lacking? Or what's the missing part that you need from them? Is it the part about evolution, like ensuring that the system can be changed while avoiding ad hoc versioning?
So as a programming language designer, let's take Rust as a model, because I think Rust is the most popular implementer of session-like types.
Sure.
Right? If you really start thinking about how you would implement remote session types, it becomes just, I have not been able to think of an ergonomic way to put this in a language where you're like talking about like a server lifetime. Mm-hmm. And I think the reason is because you need to bounce between address literals and sometimes you want an address literal, you want an actual IP address, and sometimes you just kind of want a reference to some IP address and you want that to be consistent, like kind of like how Rust does memory management.
Mm.
But how do I put this? So again, with Rust, I think it works because you're talking about, oh, I don't care exactly which block of memory I have. I just want to make sure that block of memory is reserved. But with this internet stuff, you really do need to specify specific things. You need specific blocks of IP addresses. I don't feel like those models tend to work well together. I hope that's like clear.
Well, okay, but well, at least in the research literature, I think session types are not really concerned with this sort of low-level details. It's more about expressing protocols in types, right? And so I don't really see how that's so what you're describing is a problem. The fact that you need to refer to IP addresses, sure. Sometimes you don't know the specific IP address. You mentioned dependent types, so normally you can use dependent types for this. I'm not sure exactly what you mean by dependent types when you say you're using dependent types, but the principle of dependent types is that you have types that depend on values, and you still can reason about these things even if you don't have the value at compile time, right? But you can still reason about it. Okay? And you can discover information incrementally about it and resolve things in this way. So I guess I'm not really seeing the limitation of session types, but maybe because you're talking about specifically the Rust incarnation of session types, but actually it means something possibly quite more general in research. Maybe you should look into that.
Yeah, I definitely can look into that and will. There might be existing literature that is exactly what I need.
We can discuss this more offline if you're interested. And I also was wondering that session types are. I don't think they're concerned with the evolution of systems, which is one of the problem you described, right? That you want to address. It sounds interesting to look into this, and maybe the answer is to include some form of gradual typing, right? Like maybe the session type cannot be fully known in advance, and at some point you need some graduality, right? Some more runtime checks when you cannot foresee every possible future evolution. I don't know. That's just a thought. Yeah.
Yeah, I think there are like clear implementations that would work if you were to sacrifice some. I listed a bunch of properties, right? And so certain obvious applications of session types, at least for me, like or gradual typing, it's like, okay, I get a lot of these properties, but there's some properties that I cannot obviously keep that I might want, and so I think that's like probably a fruitful next step for me, is figuring out which systems of thought allow me to keep certain properties, which implementations allow me to keep certain properties. Can I implement something unambiguously, etc.
Which trade-offs you have to make?
Because I don't even know what the trade-offs are.
Yeah,
I want to know what the trade-offs are.
Mm-hmm. Okay. Well, it sounds like a worthy endeavor. Anyway.
Worthy endeavor. Any other questions? I'm also be around all week for the most part.
Okay. If there's no other question, let's stop here. We're out of time anyway.
Okay.
And thanks to the speaker again.
Thank you.